Welcome to part 3 of week 9 of the ECE9013 course. In this part, we will be discussing one of the more efficient sorting algorithms, namely the merge sort algorithm. This sorting algorithm uses a divide and conquer approach. First, it checks if the list length is 0 or 1, which means it's already sorted. If the list has more than one element, it splits it into two lists and sorts each, and then merges the sorted sublists. So we look at the first element of each sublist, and we move the smaller to end of the result. When one list is empty, we just copy the rest of the other list. So we keep on dividing the list into sublists, and then we merge. So we split the list in half until we have sublists of only one element, and then we merge. We merge such that the sublists will be sorted after the merge. We keep on merging the sorted sublists until all the sublists will be sorted. So here is an example. We compare the first two elements. Here, for example, 1 is less than 2, so we place 1 in the result. Then we compare 5 and 2. 2 is smaller, we put 2. Then 5 and 3, we put 3. 5 and 4, we put 4. 5 and 17, we put 5. 12 and 17, we put 12. 18 and 17, we put 17. Then we copy this to the end. To do so, this is the actual code. So in this case, the left and right are ordered, and we move the indices for sublists depending on which sublist holds next smallest element. When the right sublist is empty, we just append the remaining from the left, or if the left sublist becomes empty, we append the right list to the result. And here we check whether if the element in the left sublist is smaller, we append it to the result, else we append the element from the right sublist. So the complexity of this algorithm is linear in the length of the lists. So we go through two lists, only one pass. We compare only smallest element in each sublist. So the overall complexity is linear in the length of the lists. We can also implement the merge sort in a recursive manner. So we check if the length is less than 2, we just return it. Else we take the middle point and we recursively call the merge sort. So this basically divides the list successively into halves, and then we conquer the smallest pieces first, which would be one element, before moving to the larger elements. So this is another example of how the algorithm works. We keep on dividing the list until we get to the base cases. And then we start doing the merging. So using the recursive version of the merge sort, at the first level we have n over 2 elements. At the second we have n over 4. So at each recursion level we divide the list by half. And because we have to go through all of the elements, we have n. So the overall complexity of the merge sort is order of n log n. The n part is because we have to divide it into n elements, and the log n is because of the recursive calls in which in each level of recursion we have, or we divide the size by 2. That's why the overall complexity is n log n. So as a summary, we discussed 4 different sorting algorithms. The BOGO or permutation sort, which relies on randomness and has an unbounded order of complexity. We have the bubble sort, in which we do pairwise comparisons, which we've shown to have a complexity of O(n) squared. We've discussed the selection sort, which also has an order of n squared and guarantees the first I elements are sorted within I iterations. And finally, a more efficient sorting algorithm is the merge sort, which has an order of complexity of n log n. Thank you.